Hello everyone and welcome to this Kubla Cubed 2021 launch event. Thanks for coming. Today we'll be going through some of the features we've been working on for the last couple of years and we're looking forward to showing you. So without further ado, we'll start on Kubla Cubed 2021. So the general idea behind this release was to try and tackle some of these problems that were making life quite difficult for estimators, especially on big housing projects. So we got a lot of feedback from our customers and from projects that we're involved with. And we've tried to introduce some tools that aren't necessarily about graphics and things like that. They're sort of fundamental things that are required. So we've implemented quite a lot of new fundamental changes, in particular areas like the CAD workflow, PDF workflow as well. And so we'll just go through those now. These are the first things I'll go over. So these are improvements to the general usability. This is in order to try and make Kubla Cubed as easy to learn as possible. So there were just some areas in the program that we felt were confusing, especially new users, and we could change slightly to help with clarification. So it's probably worth me pointing that out. So elements have been separated into two sections, like absolute elevations and relative elevations. So absolute is an elevation that you input that's like from a datum, like 1,000, 1,200 meters above a certain datum. A relative will be something like a trench where you're specing up by sort of like a depth of half a meter. So we've separated that out to have this concept of absolute and relative elements, and it makes some tools easier to understand. We've also renamed the strip to reduce and the spread to raise. We felt that was required because there's quite a lot of operations that require the reduce to be used to just lower the proposed level in general. And it's not a topsoil strip, so it's causing some confusion where people were not sure why they were using the strip tool to do a reduction of level. And the same to spread, we've changed them to those kind of more generic terms. So on top of that, the path element, where it was able to do heights, depths, if you specified negative heights, and explicit elevations or absolute elevations. We've split that into three, which we really think helps with comprehension, because you've got a trench which is specified by depth now, berm which is specified by heights, and a path which is specified by absolute elevations from a datum. So we've separated them out so they can be split into these two sections. That's all a bit complicated, but it'll make a bit more sense when we go into Kubla Cubed and show that. The other thing we've really done to help with usability is made sure that all elements are edited in the same way. For users of the program long term, you'll sort of notice that the feature surface has very different workflow than the platform. So it's in general more powerful. You can import from CAD, you can copy and paste outlines. So what we've done is upgraded all the elements to use that same user interface. So that's really like even the platform or the reduce and raise element, they can now be imported from CAD. You can copy and paste between them, so it's really useful. So that's quite a powerful upgrade in itself, that sort of the strip can now be defined from CAD if you want to. And as we'll be looking later on, we can also extract vector data from PDF. So that's available to all the elements, not just a feature element, because it was in the 2019 a bit like the feature element had all these tools and the rest were quite basic still. So we've upgraded all those elements and it makes it easier to kind of understand. There's not one way of doing a platform boundary and one way of doing a feature surface boundary. They're both the same. So without further ado, let's load now Kubla Cubed 2021 so we can go through some of those things. This is Kubla Cubed 2021 running. When we click on the plus option now, you'll notice that there's a sort of separation. There's reduce and raise instead of strip and spread, but they've also been split into these two. So if you're teaching a new user of the program, like maybe a colleague, it's kind of easy to explain. If you want to do a trench, you do a trench now, whereas in the past it would be, oh, you need to do a path and specify negative heights. It was like really awkward. So we think that's quite a big improvement there. To demonstrate the fact that they all use the same editor, which is a really big change, we think. So we'll go into the strip phase. And now this strip, which would have before had a list of points down here, has now got the same sort of setup as a feature surface. So you can go into the editor like this, and then we can add multiple outlines We can even import them from CAD. And the beauty of this is that we say the feature surface supported punch out, so you could do an outline within an outline to specify a kind of negative area of your surface that you're modeling. Now we can do that in all the other elements, like a strip. So I'm going to do it here in a strip. And I've just punched out a hole. It's much easier than the sort of other workarounds that we had. You also have the sort of copy and paste capability. So I could copy that outline and paste it into a feature surface or a platform. So you have that interpretability between the different elements, which is really important. So I might do another little demonstration that's kind of quite cool. So we've got a slope element down here. And before that was just one polygon used to represent the whole of it, whereas now we could do sort of more complex structures with two holes in the middle here. And we will end up, or should end up, with a sloping area, which is all controlled as one slope, so that can be really handy. So the next thing that we've really improved with workflow is the ability to add CAD files into the program as site plans. Previously, there was a feature like this that was in beta, so some of you might have been using it, but now it's actually going live for all users. So you can add CAD files into the background rather than PDFs. Now, the advantage of that is they are already geolocated, so you don't need to scale them. On top of that, they can be sort of zoomed and not lose fidelity. Another thing that we've enhanced, which a lot of people are looking forward to, is or have requested, is the ability to extract vector data from PDF files. So we've sort of done a version 1 of that capability. So that's really powerful. It is kind of the first version, so it's not going to work on all PDF documents. PDF aren't, they don't contain a lot of metadata that's necessary for extracting entities into a program like Kubla Cubed, but you can often get a decent amount of the data, and you can use that as a starting point to maybe input the elevation separately. So at the moment, our PDF extractor brings in all the entities in flat, so they'll have a 0 elevation. So that's something that we'll be looking at later, because we've also got a tool for dealing with that. So I'll just demonstrate that some of those kind of new ideas. So we'll start a new project for this, and then so when I click here on the plans menu, you'll notice that we have another option. Before it was just add image PDF file, which you might be familiar with, but now we've got this other option, add CAD file. So I'm going to add a CAD file directly from the DXF in this case, but it also supports DWG. And we can see that it's already scaled how we want it, because of sort of a virtue of using CAD over PDF. On top of that, when we zoom in, like our process with PDFs is to render them to images and then display them with the graphics card, which is fast, but when you zoom in, you end up with slight pixelation, which can be a problem with very fine text. So the CAD file has that advantage in Kubla Cubed now, that you can zoom right in and see like in like kind of real detail any areas that you need. So it works in very much the same way as the PDF does. So say if we want to remove a color, we can just click on that. So they're basically as simple as that. You have your CAD file as an underlay in your project. On top of that, if you click here, and so you'll be used to adding a feature surface, so taking off your existing, and you might have, so in the past, gone to here and clicked here and then browse to try and find a CAD file. Well, now there's this other option where you can actually extract directly from embedded files, because the CAD file is embedded. And that is quite useful, because if someone sends you a file with a CAD file embedded into it, there's nowhere to browse through. You'd have to get them to send you the CAD file separately, whereas here you can sort of extract directly from the CAD file. So I'll just demonstrate how that works. So we clicked on add from CAD file, and then we set the contours in this case. And all the contours come in directly from the CAD. I'll do the outlines as well. So you just click on that, add from CAD. It's listed, there's a list for CAD files, there's a list for PDF files, which we'll talk about in a second. And we set from the sample again. So I'm wanting outlines, so I want to select just the boundary outline. Click OK. And that workflow we think is much nicer than the previous one of having to navigate your hard drive and look for the CAD file. Now, the cool thing about this is we can also do it with PDF. So this is where we'll go through some of the PDF extraction ideas. I will say PDF isn't a format designed for transferring CAD data. So it's like fundamentally a print format. So the kind of process of extracting CAD data from a PDF can be a bit hit and miss. If it contains a scan, like you'll find that you won't be able to extract anything, or sometimes the entities aren't set up in such a way. But it's best to just give it a go, and then if it doesn't work, you can send the PDF to us. As we're looking to improve this module of our program. This is kind of version 1. So we'll be interested in, like, if you have a CAD file, a PDF file that you feel like you should be able to extract the contours and it's not working, we can kind of take a look at it. We are going to be improving that module. So for the PDF extraction process, you start by just adding your PDF exactly as you did before. So we've got an example PDF here. So this one's quite simple, sort of deliberately, so it's easy to understand. So a PDF, you're going to have to scale the same as before. So I'm going to scale using these points here, so using a known length, because I don't think there is a scale guide on that one, by length. So I think that's a difference of 75 between those two grid points. Yeah, so we'll scale it like that. So that's the same as before, pretty much. You're bringing a PDF, you're scaling it, using the measure tool to check that it's kind of in the scale that you were hoping for. So the next process is a bit different. We're adding a feature surface, and now we're going to go, okay, let's try and extract some of these contours, because they look like vectors when you've viewed it in Adobe Acrobat Reader, or when you're looking at it in general. So you're like, well, we should be able to extract these contours. So give it a go. Click on that. So go plus, add feature surface. I want to extract the contour lines. So I click on this option again. So here there is plans PDF files. It's the same way as we worked with the CAD files. So we just, rather than browsing and selecting a PDF, we select the embedded PDF. Now, the great thing about that is it's already scaled. So when the data comes through, it comes through scaled, rather than the big problem sometimes if we just extracted it from the PDF is that we'd then have to rescale the data. So that step is already done. So this is the conversion. It's done a good job of converting this PDF into its composite vectors. It's not always going to work, because some PDFs can contain raster images. So it's a case of giving it a go and seeing how well you get on. So we will set a sample as is the standard process, and it's managed to grab those contour lines out of this file. Click OK, and there they are. So they're brought in flat, but there is a tool for setting those, which we'll look at later. I'll just quickly go through that process again, because it's a new process, but this time I'll try with the building pads and bring them in as outlines. So you might do that, for instance, if you wanted to do a feature surface with building pads. So you wouldn't usually be doing that in the existing one, but for this case, just to demonstrate the process, I'll go through it. So you select that. So potentially all of these entities could be used, like the road outlines could be used to define a road. Let's see, so I'll clear the sample set from inner line. Okay, and that's grabbed a good percentage of the building pads to save me having to trace. In this example, it's not a huge time saver, but if there is, quite often we get projects with, they say 50 plots, so that would be a good time saver if you could extract those directly from the PDF. It's a case of just giving it a go and seeing how you get on, and then feel free to send email to us with the PDF or post on the forums if you're not getting the results you want, and we'll try and improve the system as we go along. Okay, so that's that section, which leads us on to the editing tools. So we've improved one thing that's quite simple, but we haven't had in the previous version of the program, is an ability to join two contour lines together and split two contour lines. So that can be particularly useful if you want to resolve a gap in the, like you've brought in contour lines from CAD and there's a gap because of the labels. It's now easy to join those two together or split them up. We also have a new tool which kind of goes in tandem with the PDF vector extraction. It allows you to select a group of contour lines and then set the first one in the selection, and then select the step between them, and it will set them all in a big group. So if you've brought in a group of PDF contour lines and they're all set to 0, or sometimes you have a flattened CAD file that also is set to 0, you can set them in one operation or a couple of operations. So that's a big time saver in itself. So we'll just go through that those tools for you, starting with the contour line. So I'll just first draw 2 contour lines to demonstrate to make it simple. So there's one at 12, and then say I've got another one at 12. So this might happen when you've got, like, you brought them in from CAD and you end up with a gap between the two. It's kind of frustrating because you're like, well, I want that to set that as one contour line. So you select those 2, and then there's a new option here which has got our new tools. We click on join, continue. 2 lines selected. Sorry, I only selected one. So select the other one. Continue. So it gives you a preview. They'll be joined at 12, and then you click finish, and then you've got the new line at finish. The other thing that you can do is if you want to split a line, you can select that line to split in the middle. So sometimes you've done maybe one outline. This might be quite common with outlines, and you want to split it. Now you can and start another one, and now you can split it in the middle, and that's quite useful as well. It's quite simple, but they're really useful tools, I feel, especially in context of bringing in data from PDF when it can require quite a bit of correction. So we'll delete those 2. So the other thing is, if you've brought in contour lines like this, so in this situation, it's brought in all but the last one. That kind of thing is a bit typical with extracting from PDF, that you might not always get 100% of the data, so you need to check. So I might trace this last contour at 168, and then it will give us an opportunity to demonstrate the new tool with that set of contours. This quite roughly, just so you can kind of demonstrate it. So that's kind of the old method of tracing contours, which we hope will be less and less necessary as our PDF extraction tools improve and people move more to CAD data. So we'll start with this one. So this is 169, 169.5, 170. So they're going up by 0.5. So what you do is you draw a line. So the set multiple elevation tool, it says draw a line, and what happens is this is the start point, and it intersects here, and it intersects here, and it intersects here, and it intersects here, and eventually here. So it builds a list of all the intersections, all the contours that intersect with the line, and then it allows you to set the elevations of the contours by that intersection order. So here I want to start at 169, and I want the interval to be 0.5 in this case. And you've got to choose whether it's ascending or descending. So in this case, it's ascending. So I click continue, and then it highlights like based on that order. So it goes from light and then up to dark. Finish, and now we'll find that all of these have been set in one operation. So this is really, in this case, we've done it with a simple set of contours. But if you had, say, 50 contour lines, this was a real time saver, especially with, like I said, the ones imported from PDF. So this one, these ones I didn't include in that, so I could set them manually. I can also demonstrate something else, I believe, here, which is if you sample a contour line from the original, you can get the information. So let's set this one to 169.5. 169.5. If we draw a line through and catch that one, so it's a good idea to sample 2 lines, and then it should be able to sort of populate the properties of the tool automatically and set that last one. Okay, so I spent a bit of time going through that because they're really powerful tools, especially that set multiple elevations. So if you've ever got a group of elevations all at 0, check this tool out because it can be a real time saver. Moving on, path, trench and berm tools. So we've really enhanced these linear element tools. which allow you to specify a centre line and define earthworks using sort of centre lines rather than boundary outlines. In Kubla Cubed 2019, there was a path tool, like I mentioned. It was quite limited in a sense that you couldn't cross paths over each other. Or if you did do two paths, they would cumulatively cut out of each other. So if you specified by depths and you had one path with one and another path that crossed it with one, it would, where they intersected, it would end up being 2 meters because they were cumulative. Now we've fixed that, so we have a new system where that's not the case. The other thing that we've integrated is the points can now be left blank, so you can have interpolations, and that can be really important. So if you have a trench line and you know that the it starts at 1 and finishes at 2.5, then you can just put those first 2 points and it will interpolate the others. You can leave the others not set in a similar way to you do with break lines in the feature surface or varying level outlines. So like these lines intersections are also resolved elegantly. In the case of absolute elevations, there's an average done where they intersect. In the cases of trenching, they also will be resolved elegantly. So this is included in the price of the Pro. Like some of these estimating packages, they'll have the trenching as a separate component, whereas this is all part of the Kubla Cubed Pro edition. So it's actually, with these new enhancements, we believe a really powerful trenching option for doing your trench networks. It wasn't necessarily that easy to use in the past, so I'll demonstrate that now, and we'll try and do some basic trench setups. I'll just load a sort of base to work on. Right, so the trench, then the absolute path, that's where we can specify explicit elevations like 1002, 1003. The trench where we'd specify depths, and then the berm is the opposite, you specify heights. But we'll demonstrate here with the trench, but the principle kind of is similar in the path. Certainly in the berm it is. In the path, it's kind of quite similar as well. So the path we would recommend for doing walkways and footpaths, simple roads. Roads are quite complex, they're sometimes better done with the feature surfaces and break lines. And the berm is obviously for dikes and bankments, levees, that kind of thing. And the trench is for trench and ditches. So we'll start with just doing a basic trench. So it's the same editor as the others. So it has that copy and paste functionality that I talked about. You can import them from CAD. So that's really useful. So we're clicking on points and we're just putting here depth. So we put 0.5, 0.8. Then I will leave one blank. So it says type level or leave blank to interpolate from adjacent points. So continue, continue, and then I'm just pressing enter to continue. Then I'll add one at 1. So that's our first trench. So we'll just click OK to see what it looks like. And here, once you've created the center line, you can then set the width. So we'll have a look at that in 3D. So here's a new trench. So you set that to E. So pretty much this is the same as 2019, apart from the fact that I was able to leave those points empty between them. So what we'll sort of demonstrate is the ability to add another trench and have it intersect, and we'll show you how that kind of gets resolved. So let's see, we'll do another one. We'll put that at 1. We'll put this trench at 1 just for this demonstration. So what would happen before is where it intersected, it would kind of be 1 plus whatever the other trench is in the area of intersection. So you get 2 trenches and you would get one area where it would kind of drop down, which isn't usually what you want. Usually you want what we've implemented here, which is a sort of much nicer resolution where the deeper one takes precedence. So in this case, you can see that it's where they've crossing over is the one at 1 that sort of dug out deeper, but it's not gone twice. It's not sort of doubled the operation. So using these tools, you can do sort of, pretty much any trench network you like. You still have the ability to add multiple trenches or multiple berms and paths, but you can define a whole trench network at 1. The reason that you might want to split them up is that they're different widths, because a trench network shades the same width. So that's something to think about. Moving on to, I think, the last thing now, which is maybe, or the second to last thing actually, which is maybe a bit complicated. We found with Kubla Cubed 2019 that like a lot of stuff was kind of simple to explain to an extent, but then it didn't quite do what people wanted. So this was a sort of situation with the way that depths were specified and heights were specified. They would be depths from the previous element. So that's what happened in the previous version. So that's what added to the cumulative effect. If you did a strip over a strip, then it would strip twice. The depth where they intersected would be cumulative. It was the same with the trenches. So we resolved that with a new system. So I'll demonstrate that sort of concept. So this applies to strips, which are now called reduce elements. It also applies to people who use the strip method, which will now have to be called the reduce method, for subgrade adjustment. Both of those required for you to make sure you were careful about your intersections, because where they intersected, the sort of like depths would be doubled, which was rarely what you wanted. So we can actually demonstrate what used to happen by I'll do one strip here at 1 meter to make it obvious, and then we'll do another strip here that crosses over this one at 2 meters. So you set it after you've created it. So we set it here. So the previous system, we'll turn off the current system, which is on auto at the moment. The previous system was to be previous elements. So we've now, like before, there was no option here, but now we're explicitly saying, so you can always, if you want to change back to the way it used to work, you can switch it to previous element. And that's how it worked in 2019. You have this effect. You have one depth here at 2, one depth here at 1, where they cross it's at 3. Now that's not really what you want. Most of the time, what you want if you've got an intersection is for one of them to take precedence, which we already sort of do with the absolute elements, with the sort of order matters. So the one lower down in the order takes precedence. So what we've done is we've implemented this new auto thing and this ability to set depths from either the ground or specify an element. So what this auto thing does is sets it to what we think is appropriate in almost all circumstances, which is it sets the depth from to the first absolute element higher up in the list. It's a bit complicated, but in general, you probably can just leave it turned on to auto, which is the default now, and not worry too much about it. So in this case, you can see that the reduce 1 has taken precedence where they intersect at 2, and the reduce this one at 1, which is higher in the order, has less precedence. So where they intersect, that gets sort of obliterated. If we change the order, you can see the effect that has on the 3D model, that the other one pops up because it takes precedence. So this is useful in strips to an extent, but what it's most useful for is if you were trying to adjust the levels of a sort of a group of contours, for instance, with what we used to call the strip subgrade adjustment method. So if you're not familiar with that, this part might be a bit confusing, but if you are, hopefully it sort of makes sense and you can see the power of the new system. So what I'm going to do is load that building site example back up again. So I'll delete these two. So there's two methods for adjusting to construction thickness or subgrade. Site plans will usually be marked in the finished floor level. So you need to make an adjustment. So there's two ways of doing that. You can watch some videos on YouTube about how to do that. One of them is to separate your project into different elements that override each other, and then use this option to specify levels and offset and put a negative Z there to adjust. So that's not changed, that's still available. But there was another method which was to add strips, now renamed to reduce elements, over the top and reduce the element that way. Now, that used to suffer from the same problem as the strip, is that if they intersected, it would then reduce cumulative, which we don't want. So now the new system sets it to adjust from the finished levels here. And so if they intersect, because the depths are from the finished levels, where they intersect, one will take precedence. So we'll do a general reduce in here. So if I say I want to reduce this level by 1, let's do something a bit more realistic. It would be 0.4 a finish. So you might be able to see in the model that area has been reduced. So we've got the original contour lines from the finished levels, and that area has been reduced. Now auto is on, and the depths from finished levels. So the depths, when the depths I've entered of 1 is a reduction from the finished levels, not from the previous element as it was before. That's not doesn't make a difference when there's just one, but when you actually have an intersection like we'll do now, so I'll do this central kind of section as a separate element, as a separate adjustment. What would happen before is that I would have to calculate what, so this one is 1 and I want this to be 0.5, so I've actually got to do that as maybe a spread to kind of move it up, so it'd be really awkward. So instead what I know now is that this one, if it's also set to auto and from finish levels, actually overwrites this one, so I can set this one to 0.3 and that section will be 0.3. This area here will be 1. So it's a really powerful system and really upgrades the capability of the subgrade adjustment functionality. And we'll be doing a video specifically about this because it is quite complicated. But in general, it's definitely worth playing around with. We would advise almost all circumstances require auto to be turned on, and it will automatically, so it dynamically adjusts what element that it takes it from. So for instance, if we were to move the reduce element up to the top, the auto switch will set the depths from ground because there is no finished levels underneath it. So the depths have to be something higher up in the stack. Now that's quite technical and complicated to explain. For some people, it's not that relevant. So if you don't understand it, don't worry too much because it might not really apply to the work you've been doing. But it is a real improvement on that subgrade adjustment capability. So the final thing we'll move on to is the reports. So this is another area we've enhanced with the addition of the ability to break down the report by element in a much better way. A lot of people who are doing things like housing estates and using the offset method to kind of you build up a series of layers or features that override each other in the area of intersections, and then you offset each one separately. The problem with that is that we'd report as a big blob in the end of just a big cluster of earthworks. So you wouldn't get a cut and fill for your roads or your building pads and the shared drives. You would just get one earthworks for the whole thing. So we've enhanced the system now. So I'll demonstrate that here. So let's say we've got, or do the offset method for here. So in general, you've got your finished levels there. So they might have an offset minus, say you have to put a negative offset for this method. We've got another building pad here, which is platform here. And that where that intersects, because it's lower in, it's on the same phase and lower in the list, it will override the finish levels in that area. And we can put a different offset on this. So in general, what you're doing with this method is you break the site up into different areas of adjustment, and you do a different feature surface for each, or platform if it's a flat area, for each different area, and you build it up that way. So it's actually quite simple to do. It's quite a simple method in some ways. And I've renamed these finished levels. So I'll rename that too. So in the past, this would have just reported as one amount of earthworks. So you would have had to use the volume regions maybe to try and trace around each of the different areas. It looks kind of easy on this, that would work, but when it came to really big building sites, that's a lot of tracing. Apart from that, the volume region actually splits up the mesh. It like kind of cuts the mesh into different chunks to do another calculation, which is computationally difficult. So you're quite likely for that to kind of not be able to give you the full report, because at some point it might fail to break that down by volume. So this new technique we've got, basically we take all the triangles at the end and we say the last element to have modified that triangle, and we report the cut and fill in that element. So what's happening is in the areas of intersection, the lowest one in the list will report that. Another way of looking at it is that if you look at the 3D, it's the one that sees daylight. The parts that see daylight report in the elements. So the finished levels are just going to be reported in the bits that see daylight. Same for the shared drives, and the same for the finished levels. If you change the order, not only does the model change, because like the precedence changes, but it will change what reports in what. So without further ado, I'll try and do this earthworks estimation, and So we've got the finished levels, we've got the shared drives, and we've got the garages broken down by region, even though they're intersecting. It seems like a small thing, but that really is a big problem for when you've got like a big housing estate with say 50 houses or something like that, or 150 houses, and it's a lot of work to just get it to calculate, cut and fill, and then it's a huge amount more work to try and get it to break down in a more granular fashion. So this is like a real important part of the upgrade, even though it doesn't look so fancy. It's quite a powerful new thing. So just to finish then, we'll talk about some of the things, unfortunately, that we weren't able to get into this release, but we are working on. So we are working on an offset tool. We've done a lot of the work for that, and we will be doing that in a future update this year. A lot of people have requested that the list of features is ordered, so they can validate. It's much easier to validate if you order the list by, say, Z, then you can see if there was one left at 0 or very low, you can just order the list and see which one it is by being at the bottom of the list. So that's something that we're going to be putting into the program quite soon. And grouping areas and lengths, so you can have a group of lengths. This is just standard sort of takeoff stuff, which at the moment isn't in the program. We did want to get into the program, but we had a few setbacks this year, so we with everything going on, so we've been had to cut those out. But for people who sort of requested those, which I know there was quite a few of you, we are putting that in. Like in the case of the offset tool, we'll be working on that very soon because we've done half the work. We've got the actual tool working, it's just the user interface that we need to work on. Long term, we are working on a lot of the other, we've got a roadmap with a lot of the other features people have asked for, like material support, boreholes, etc. So we are actively developing these tools. So if there's something that you were hoping that is in this release and isn't quite there, maybe post on the forums. We've got a section where you can post feedback and suggestions. So yeah, post on there, say, I'd really like to see this feature, and then we kind of prioritize the stuff that's requested more. So that comes to the end of this presentation. We hope you like it and it really helps with your projects. We have a bit of time for any questions. On Microsoft Teams, there's should be a speech bubble with question mark on it where you can post questions. So I'll give a few moments for anyone to type any questions that they have about this release or anything in general. So someone's asked, how large data set can the program handle? That's a good question. So that's something that we get asked quite a lot, especially in relation to sort of drone data. So you might have say 2 million points or something that you've surveyed from a drone. It depends quite on the power of your PC. Like obviously if you had a desktop with a Intel i9 or Ryzen, like AMD Ryzen 9 processor, you can handle a lot more data than a laptop. Also, the amount of RAM that you have, like if you have 32 gigabyte RAM, you'll be able to bring in a lot more data. In general, though, you're not looking at drone levels of data with TIN modeling because it's not as efficient as a point cloud system in terms of its kind of way it renders and stuff. So those systems that render points can render far more than this, where we're rendering triangles and dealing with triangle prism operations. So like surfaces of 100,000 points will be okay. Maybe if you have a very powerful machine, you could be looking at more 200,000, but you're not looking at the kind of million data sets that you get with drone surveys. So what we do have in the program are points thinner. So if you bring in a load of points, there is an option to thin the points down. So that is something to check out as well if you've got large data sets. But if you do work with a lot of drone data, it might be worth, there is a lot of these packages for reducing the size of the data set down, which is probably a good idea when using in tin-based estimation packages like Kubla Cubed. We're always working on that, so we are working on the next generation platform. We'll be hopefully able to handle a lot more. But at the moment, we do have a test one, which is I think 80,000 points. So yeah, but we have that coming up. The next question we've got is Doug has asked, I'm currently using Kubla Cubed 2019 5.14, which is the latest version. How do I get the new version? So if you're a subscriber, when you open Kubla Cubed, it should detect that there's this new release available, and it will give you a prompt. So by the end of the week, if you haven't received that prompt, then get in touch and we'll send you the installer. But most of the time, unless there's a firewall set up that blocks kublasoftware.com, you will get that prompt saying there's a new version available for your subscription, so then you should download that. If you're a perpetual user, we'll be automatically sending sort of upgrade offers for the perpetual users, so you get a discount depending on how close to the launch you purchased. So if you don't receive those, get in touch as well, if that's okay. Someone, Nico's asked whether they can download it today. It's not ready today, unfortunately. This is the launch, just showing the features, but they won't be coming out until next week. But one thing I would say at this point is if you're working on a project, it's best to stay on 2019 for now. We don't advise for you to upgrade mid-project. So it's kind of a good idea to stay with the projects that you're working on 2019. When you upgrade, you should be able to access both 2019 will stay on your system. And then you can kind of carry on 2019 and use 2021. So yeah, Nico, that release, that download will be available next week for you to download. And if it's not, get in touch with support@kublasoftware.com and we will make sure to upgrade for you. So I think that's all the questions for now. Thanks for tuning into this demonstration. And we look forward to your feedback and suggestions either on the forums, or you can email us at support@kublasoftware.com. Thanks for watching and have a good day.